Hi. In the last chapter, we studied about the viscosity measuring element. In this, we are going to look at UK 100V, the controller which is used to link to the viscosity sensor and do all the action. Here is a look at the controller. As you can see, there is a large LED display which always displays the current value of the viscosity, and this smaller LED display shows the set value of viscosity around which we want to control this viscosity. And then we have alphanumeric backlit display which is used to set, monitor detailed status of various parameters and variables. And then there is a set of 5 keys with the help of which we feed the values and operate the instrument as a whole. Okay. Now apart from this, there is a set of 8 LEDs, mimics, which indicate the various inputs and outputs which provide valuable information to the user during the operation of the instrument. Now let's study about the different menus. Okay. Now let's see. This is called the default menu. In this you can see there are 4 viscosity values which are the last 4 readings of the viscosity control, and this is the average. Now there is a provision in this controller to either use the average or the latest reading for the working, that is for control, for display and everything. The parameter is provided for the same. Now in this case we are using the latest reading. Okay. Now let me go to this. Press more key, you will get the go to the menu. This one is the default menu, which is the same thing, whichever you saw it. Now we go proceed, we get to the set value. Now let's say this is a set value of 375. Let's say I want to change the viscosity set value to 360. Okay, put like this, it becomes 360. Now there is another channel here, temperature, J temperature and D temperature. 2 temperatures are provided because viscosity is generally associated with temperature. These channels, one of them can be used as control channel and the other one is purely a monitoring channel. Okay. Now press mode and come. Now again we are coming back to the same display. This is the default display. Okay. Whenever you go from anywhere, you just press mode key and press this, you will come to the same display. Whenever the power is off and on, this is the display. This is the default page. Now let's go to the next. This is the parameters. Now these are the parameters which are going to decide how in what mode this control is going to function. Now there is a password for this because we don't want unauthorized access. So after pressing a password you get to know these. These are the different parameters. They include the sampling period of the viscosity reading, conversion factor, control parameters of the viscosity, and temperature, amplifier characteristics, as well as the alarm limits for viscosity and temperature, and for PC interface parameters, and so on and so forth. This list is given in the manual, so you can go through that and understand the same. The parameters are not supposed to be changed frequently. For a particular application, generally once if you set the parameters, it is supposed to run all along. Okay. Now what is the next menu? The set value we saw, parameters we saw, now RTC. This shows the real time of the day. Real time and clock and calendar. This RTC is provided for data acquisition purpose. There is a provision in this controller to store the readings on real-time basis at set intervals of say 5 minutes, 10 minutes, like that, and then each reading is associated with a time basically, and such 3000 readings can be stored and then later on downloaded to a PC for study of the historical study, record how this viscosity control functioned and what was the status of the product at that time basically. So for that purpose this is used. This has got a battery backup obviously, and parameters have they are all in non-volatile memory. Now we have diagnostics. This diagnostics is generally for our purpose. During the working of this, there may be some issue with certain sections of the program, so to identify them, we have this page. It is purely for the manufacturer and not much importance to be attached by the user. Then we have configure. It's also the same thing, but here we have provided additional thing. When you press this, you will see the LEDs glowing one by one. This basically indicates the health of the LED mimics, whether the LEDs are glowing properly or not glowing or glowing unnecessarily. Because by looking at this LED display, the user gets valuable information about the status of the process. Okay. Then I go to the last one, which is data handle. The data stored in the instrument, the data dump is now removed because the data dump is done by the PC itself. Now data clear. When the data is fully, the data storage is overflown, then there is a indication on the display, buffer full. At that time, the user goes here and presses enter to clear this. Once this message comes, the data is clear. Okay, that's how it works. Okay. Now, there is also a key which is reset key. Instead of switching off and switching on sometimes when you are out, then you can just press the reset key and then it works in the same fashion. Okay, you see the sampling is taking place. So this 1 number LED is for air solenoid. So once this is on, in the element, the piston goes up. Okay, this is air solenoid. Now, after the sampling period is over, this signal will go and the piston will drop. Just wait, we'll see it again. Sampling period is set for 30 seconds, so after 30 seconds it's supposed to come down. Okay. Yeah. This is the first indicator. Upper photocoupler is a lower photocoupler, which will also come down. Yeah. See. Now this is the water addition signal. Water, or you can say solvent addition signal. To dilute the liquid, this signal comes. So I hope you understood. Because this value is higher than this, solvent addition took place. Now solvent addition depends on the difference between the two values. Generally, if the obtained value PV is less than SV, generally the solvent addition is not there. But if it is above this, solvent addition takes place and it follows a linear formula, Mx plus B. Okay, so the duration of water addition depends on the difference between the two values. Now again you see this has dropped, again there will be water addition. Okay. See, we are showing you in this demonstration in an open loop condition. There is no solvent addition actually happening, so you can see that continuously water will keep adding. In fact, addition signal will be coming. Okay. Now there are only 2 readings yet, so this is average is less. Once all the 4 readings are there, then it will start showing the correct values. Okay. So that's it. I mean, this is a brief working. Okay, we can observe 2 more readings and then we can close this chapter. Before, okay, so now the 3rd reading has come. Let the 4th reading also come. Sometimes, due to some reason, the sampling does not take place. Maybe because of lack of air pressure or due to some reason. Then how does the instrument restart? How does it sample by itself? There is a value in the parameters where period is entered, and if there is no new reading in that period, the instrument again attempts to restart. Okay. And if 3 such attempts take place and still it is not able to restart, then no operation comes and alarm comes. Okay. So that's how it happens. So you can see now all the 4 readings are there, and now this will go on and on. Okay. So you want to see NOP, that no operation when it comes, you can just switch off your air supply and see that it attempts 3 times to take the reading, and if it fails, then no operation comes, and the operator from alarm or from a distance he can make out that the air pressure has dropped. So he comes and adjusts the same, and the instrument restarts itself. Okay. These are a few things which are provided in this. So long then, that's it. Okay, bye.